So molar conversions is a very basic concept in chemistry. It's going to be very important when we do stoichiometry later. It's based on those unit conversions and the factor label method that we talked about when we were converting between standard units and metric units. It's going to use that tic-tac-toe board method. The different thing that's going to be a little bit easier, I think, is the conversions are easier. Instead of having to remember how many centimeters in an inch, how many gallons, in a kiloliter, those kind of things, all you have to remember is 3 molar conversions. So the first one is a mole can be equal to a compound's molar mass. Now the molar mass of a compound is going to be measured in grams per mole. The mole is actually what it's equal to. 1 mole equals an X amount of grams. This is calculated for each compound. So if you don't remember how to calculate the molar mass, you use the periodic table, you add together all the atomic masses, etc. and so forth. If you don't remember how to do that, go back and review that video before you continue on with this video. The second thing a mole can be equal to is 6.02 times 10 to the 23rd molecules, atoms. This can be electrons, basically anything that's very small. This 6.02 times 10 to the 23rd, that is Avogadro's number. That is the person who discovered this. And finally, the third thing a mole can be equal to is 22.4 liters. There is some stipulations with this 22.4 liters. It's always of a gas, and it's always at STP. STP stands for standard temperature and pressure. There are certain conditions under which the gas exists. We'll talk about that more when we talk about the gases, and we do gas conversions and those kind of gas problems. So the easy part is you only have to know those 3 conversions, and you can do any of these molar conversion problems that we're about to do. The same rules apply as with what we did before. You need to start with what you're given. It would be good to highlight or circle in your problem. So we're just going to go ahead and start with number 7 here. So it says how many grams. So what you're looking for is grams are in 1.5 times 10 to the 25th molecules of CO2. So again, just like we did with the unit conversions, you always start with the number that you're given in the problem. So here I have 1.5 times 10 to the 25th molecules of CO2. Now, it's going to be important that you this time include what the compound is, the formula of the compound. Because remember, to calculate molar mass, like we do up here, molar mass, you have to calculate that based on what the compound is. So that's why you need to include that it's CO2. All the same rules apply. If you're going to go from molecules and you want to get rid of molecules, it's going to have to go opposite so you can cross it out. So that is everything that we've been doing with all the molar conversions. If you want to cross something out, it has to go opposite. Now, you cannot convert directly from molecules to grams. There's a little picture you can kind of make for yourself that'll help you remember how to convert from some things. Mole is kind of your take-home. Mole is kind of how you get to everything. So if we draw this little picture here, you can see that from a mole, think of it kind of like a train stop. If you have a mole, you can get to any one of the 3 units. You can go to moles to grams, moles to molecules, moles to liters. Any of that is fine as long as you have moles. But notice you cannot go from one unit to the other directly. You can't go from molecules to liters. You have to go to moles first. Moles is kind of always your stopping point. So in this case, it's asking you to go from molecules to grams. So notice, here's molecules, here's grams. There's no way to get there directly. So what you have to do is molecules to moles to grams. And you're going to find that's the case in most of these problems. So my first step is I'm going to go molecules to moles. So we're going to remember that molecules is already on the bottom, so I can cross it out. You're going to write 1 mole of CO2. And then the conversion is Avogadro's number, 6.02 times 10 to the 23rd molecules equals 1 mole of CO2. So I stop now, I'd be in moles, but I want to do one more step. Again, I want to get rid of moles. So 1 mole of CO2 goes on the bottom. Cross that out. And then here's the key. 1 mole equals the molar mass. That's the conversion here. 1 mole equals the molar mass. The molar mass is calculated depending on what you have. In this case, you have CO2. Here's an easy way to remember. Whatever compound formula you have down here, so this says 1 mole CO2, the mass that you put up here needs to match. They should match vertically. So moles of CO2 on the bottom tells you need to have the molar mass, the gram amount of CO2 on the top. And you can plug that right into your calculator. Again, you can go ahead and review that video of calculating molar mass if you're not sure about that. But the molar mass of CO2 is 44.01 grams. Then you're going to do the math here. There's a couple ways you can do it. You can multiply everything on the top. So I can do 1.5 times 10 to the 25th times 1 times 44.01. And then 6.02 times 10 to the 23rd times 1. Divide those. You can also do it, remember, if you multiply or divide by a 1, nothing happens. So you can do it kind of in a line. You can do 1.5 times 10 to the 25th divided by 6.02 times 10 to the 23rd times 44.01. Doesn't matter which method you choose, but your answer should be 1,096.60 grams. Remember, it doesn't have to be exactly that number. If you're a little bit off, that's okay, but it has to be very close. I know my final unit is grams because that's the only thing, remember, only unit not crossed out. Okay, so the next thing, I'm going to go to the next problem. We're going to highlight first. It says, what volume would CO2 in problem 31 occupy at STP? Now again, a little bit of a boo-boo. This should say in problem number 7, so it's talking about the previous problem. So it's asking now, what volume would this amount that we just talked about, the 1.5 times 10 to the 25th molecules, occupy? Now you do have two options. You can pick either this starting number or this starting number. You can either start in the grams we calculated or in the molecules that you're given. I will give you a hint. You should pretty much always use the amount given in a problem to start with, so 1.5 times 10 to the 25th molecules. And the reason for that is if your answer to number 7's wrong and you use that to answer number 8, well, now you've kind of set yourself up for disaster. So if you use the actual problem, then you know that at least, your 8 could be right even if your 7's wrong. So again, I need to go from molecules to volume this time. I cannot, remember volumes measured in liters, I cannot do that directly. I have to go molecules to moles to liters. So I'm going to do 6.02, Avogadro's number, 10 to the 23rd molecules on the bottom. Remember, so I can cross molecules out. 1 mole of CO2 on the top. If I stop now, I'd be in moles. Now I want to get rid of the moles, so it goes on the bottom. Cross it out. And now remember, you're looking for the volume this time. So your conversion for volume is 1 mole equals 22.4 liters. Again, you're going to choose your math, either multiplying the top, multiplying the bottom, and dividing, or doing it as you go. Either way, your answer, we're going to squeeze this in here, should be 558.14 liters. Okay, and the last problem here says a sample of NH3 occupies 75 liters. How many molecules is this? So again, the nice thing is it's the same thing every time. You always start with what you're given. In this case, it is 75 liters of NH3. You're going to go from liters to molecules. You have to go through moles. So liters goes on the bottom, so you can cross it out. 1 mole of NH3 is going to go on the top. The conversion is 1 mole equals 22.4 liters. Then we're going to get rid of the 1 mole NH3 on the bottom. Opposite crosses out. And then we're looking for molecules. So we're going to do 6.02 times 10 to the 23rd molecules. Again, math is your choice, but your answer should be around 2.02 times 10 to the 24th molecules. Please remember when you plug these numbers that are scientific notation into your calculator that you're putting them in parentheses. So remember that these numbers, so if you're plugging in the 6.02, for example, should look like this in your calculator. It should be parentheses 6.02. And then what you should really do is hit the second button on your graphing calculator and the button above the 7 that looks like a comma, and this little E is going to appear. Remember that stands for times 10, and then you simply just do 23rd and close the parentheses.